Okay. Two boys are sliding towards each other on a frictionless, ice-covered parking lot. Jacob, mass 45 kilograms, is sliding to the right at blah speed, and Ethan, mass blah, is gliding to the left at 10 blah along the same line. When they meet, they grab each other and hang on. So, what is their velocity immediately thereafter? So, since they are gliding along the same line, I knew that this was just basic linear momentum stuff. Nothing special at all. So here's the little picture. Here's little Jacob. He's going this way. Ethan's going this way, and then they're gliding together. Important note: they're moving along the same line. They're wearing the little ice skates. That's what those are supposed to be. And then here's the math. So initial momentum is final momentum because nothing's going anywhere, no momentum's going anywhere. This is their initial, and then they're moving together at the end, so their final velocity is going to be the same, and it's going to be their mass added together. So then I just plugged everything in, and I got that they're moving at 0.6066 meters per second. What fraction of their original kinetic energy is still mechanical energy after the collision? So this is just looking for a ratio. So it's just final over initial. Their final, since they're moving together, is just this kinetic energy of them moving together. Then the initial one is each of their kinetic energies originally, so that's just half mv squared for all of them, and then you just, this is J for Jacob, E for Ethan, and then the halves drop out. This was all given. This is their masses added together. This is the velocity I found in part A, and you get 0.447%. One thing I thought, I don't know why they ask these like random questions about like ratios and stuff when it comes to WebAssign. Like I don't know why we would need it, but you know, whatever. I guess it's important to see like how much of their energy they lost. But I don't know. It just seems a little silly. It feels a little silly. Okay. That was so much fun that the boys repeat the collision with the same original velocities, this time moving parallel lines 1.08 meters apart. So then they lock arms and they rotate. Okay, whatever. Here's the picture. This is them moving along different lines. Again, they're in the same direction, whatever. Then this is them moving together. As you can see, they are rotating. This is their center of mass. Those little blue dots are center of mass, and their little center of mass is going this way. I put it on Jacob's arm and on Ethan's arm because Jacob weighs a little bit more than Ethan. I never found their actual center of mass, so I couldn't give you like a distance for like how far apart this is, but I know that it's going to be closer to Jacob because he weighs more, and then it's going to be this way because, again, this is the way that Jacob's going. Jacob has more momentum, so they're going to go this way. So find the velocity of their center of mass. So since because of kind of this image, I knew that they would move at the same speed here as they did here because it's pretty much the same question. Since they're moving together in the end, and it said their center of mass, I knew it was going to be the same speed because it's like the question is the same pretty much. Like you would do the same math for it. So I just kept this speed. I didn't really do any math. I just kind of like figured out like, okay, it's asking the same question. It's the same initial speeds and the same like initial weights or masses, and they're moving together even though they're moving in a circle. It's their center of mass, and their center of mass isn't accelerating or anything, so I know that it has to be moving at a constant velocity, and that constant velocity would be the same if they just collided linearly. Find their angular speed. This part, this was the momentum WebAssign. So everything in me was trying to solve this with momentum, and it just wasn't working. Like, it just wasn't working, and it literally bothered me so much. I worked on this problem for like 3 days straight. I extended this WebAssign just to solve this part of the problem, part D of this problem, and it was literally so easy. I just had to use energy in that momentum. So I already used momentum once. Like, I guess I should just, like, you don't always have to use like the obvious model is kind of what I got from this problem. But anyways, initial is final. This is their the kinetic energies of each of the people, of Jacob and of Ethan. And then since they are rotating, you have to find their rotational energy, which is I omega squared. And, whatever. Okay. MR squared, because it didn't give me anything else, and it didn't say what, shape they made, so I just assumed it was I omega squared, or, not I omega. I just assumed it was MR squared, and it worked out well for me. So then I just, I solved for it. This 76 kilograms is them added together, and this 0.54 meters is half of 1.08. I don't even know what the answer was. Anyways, I didn't even write the answer. But I do remember it being 0.3 meters per second off, and I realized that I should have just I should have found their center of mass, and then this answer would have been exact on the dot. So that was one thing I should have done, but I just didn't, because I was just so annoyed and it marked it right, and I was just okay, we're done. I finished the problem. Okay. What fraction of their original kinetic energy is still mechanical after they link arms? Since I set their initial to final, set them equal to each other, I knew it was just going to be a 1-to-1, so it's 100%. I guess the reason that they made me do this twice is to see how much of a difference these two are, but it just still feels